Welcome back. In this tutorial, we're going to look at heating up a substance through phase changes and calculate the heat added or heat lost. So here is a graph. It is a graph of water, and you can see what happens if we start with ice at the bottom left. As we gain heat, it increases, but then we hit this plateau, and all this heat energy is being added, but it's not increasing the temperature of the ice. All of that heat energy is going into melting the ice. Once the ice is melted, and we hit this point right here, then all the ice is melted, we have 0-degree water. Once we have 0-degree water, the heat energy goes into increasing the temperature of the water until we hit 100 degrees. Once we're at 100 degrees, all this energy is going not into increasing the temperature stays 100, but it is going into changing it from water into steam. And so the steam, the water and the steam coexist at 100 degrees Celsius until all the water is evaporated and we have only steam at 100 degrees. Once that happens, now the heat energy is going into increasing the temperature of the steam again. So we actually have 5 different phases here. We have the first phase, which is down here, of increasing the temperature of the ice. We have this phase, which is going into melting the ice. We have this phase, which is increasing the temperature of the water. Then we evaporate the water. And finally, we increase the steam energy. And all of these things require different amounts of heat. So when we're calculating this, we can't just use Q equals mc delta T. We have to use a slightly different equation. And that equation is right there. So you can see we actually have different terms going on here. We have 5 terms, and the reason we have 5 terms is because we have the 5 different parts. So you can see here we have our solid, and this is the energy needed to heat up our solid, this portion of the graph. This piece, this LF term, LF stands for latent heat, and the F is fusion. So that is the fusion between a liquid and a solid. This piece, mc delta T, is the heat needed to increase the liquid or the water. We have this LV term. This is our 4th term to evaporate or vaporize, which is why the V, it's LV. V is for vaporization. So that's the energy needed to vaporize the liquid to the gas. And this last term is for the energy needed to heat up the gas. So we're mostly going to be dealing with water, and you guys are going to need a few more pieces of information before we start a problem. The first thing we're going to need is some constants. And you already know the specific heat, C, of water is 1. There are some other ones that we need to know as well. So here we have latent heat of fusion, LF. For water to ice, it's going to be 80 calories per gram. That's just a constant for water. And we also have LV, latent heat of vaporization. That's the upper part, and that is 540. So those are just constants that we can plug in when we're dealing with water. And we also have the specific heat that I was mentioning. And the specific heat of water we know is 1 calorie per gram degree Celsius. But we also need to know steam and ice, and fortunate for us, they're both a half, which makes it easy to deal with. So, let's do an example. Our example is how much heat energy is needed to raise the temperature of 100 grams of ice at -50 degrees to form steam at 150. And actually this example is a little too, I don't want to get you guys confused. We're actually going to cross off the 150 and we're going to make this 160 degrees, just to keep the numbers a little different. So, first off, we need our equation. So we have Q equals mc delta T. This is for the solid, plus mLF for the converting it from a solid to a liquid. And we have mc delta T. This is for the liquid, plus mLV. This is vaporizing it, plus mc delta T, and this last one is for the gas. So, for our problem, this first term is heating up the ice. So we have 100 grams of ice. We need the specific heat of ice, and that's one of those constants I just gave you. That was a half. And then we have the change of temperature of ice. Well, the ice melts at 0 degrees. So if we just look at the ice, how much heat, what's the temperature change of only the ice? Well, we're going from negative 50 only to 0, because that's where the ice melts. So our delta T is 50 degrees, because it's warming up from negative 50 to 0, and that's the end of the ice. That's the end of the solid. The second term, we have a mass of 100. We need L sub F. That is a constant. For water, it's just 80. Plus, now we're heating up the liquid. We're heating up the water. So we have 100. Specific heat C of water is 1. I'm not going to write that down. But we do have delta T, the change of temperature of the water. Because we're going all the way to steam, we're starting at 0 degrees. And it's going all the way to 100 degrees. That is how far the temperature is changing through the liquid. So we have 100 degrees. Plus, our mass is still 100. LV is a constant. It is the constant I gave you at the top, which was 540. All right, and this last term, we have the mass, which is 100. Get a little more room here. The specific heat of steam, because we're dealing with our gas, is 0.5. And I need a temperature change for the gas. Well, the gas starts at 100 degrees. That's where it turns from water into steam. So it starts at 100 degrees, and we're only going to 160 degrees. So the change in temperature is 60 degrees, from 100 to 160. So once we have this, we can just go straight into math. We have half of 100 is 50 times 50. This is 8,000. This is 10,000. 54,000. And we have 50 times 60. And we're going to throw this all in the calculator, and we are going to get an answer of 77,500 calories. So basically, we're just using the Q equals mc delta T, and up until now, we've only been dealing with very specific examples. We've only been dealing with examples of water or examples of solids, where we're only dealing with one of these terms. But really, if you change phases, you're going to need more. Also keep in mind, if the example is starting at 0 degrees ice, and it turns into a liquid, and we heat up the liquid, we don't need all of these terms. You definitely don't need the vaporization term. You definitely don't need the gas. And if it's starting at 0 degrees ice, we are not heating up the solid. We're not heating up the ice. The ice is at 0 degrees. So the only two terms you would need would be to melt the ice and to heat up the water. So sometimes this big equation is a general equation, and a lot of times some of these terms are going to be 0. So only use the terms you need. And once again, the terms, this term is heating up the solid. This term is melting the solid. This term is heating up the liquid, vaporizing the liquid, and heating up the gas. So just you have to think about what's what, and make sure you put the right constants in the right spot. It's really not that difficult. All right, thank you very much.